Okay, on this video, we're going to go over some examples on how to simplify using the power rule for products. So the property to use power rules for products says that if you have, let's say, A times B, or AB, to the n power, then this becomes A to the n times B to the n. So pretty much that n gets distributed between everything inside if there is a product. So let's keep in mind that this is a product, or they are being multiplied. So if we have an addition, if we have a subtraction inside, then we're not allowed to have this. This is only for product, or we can say a division, which is a fraction. So we're only allowed to use this when this is a product. So for our first example, we're going to have k to the 4th power and then to the 7th. So this is just a simple example in which we can go ahead and directly apply the power rule. We are not multiplying anything inside. We only have k, right? So we can just go ahead and multiply our two exponents. So this becomes k to the 4 times 7, which is k to the 28. And that's it for the first one. For the next one, we're going to have 2k to the 10th times m to the 3rd power and then to the 6th. Now in this one, we do notice that we have three different values inside. So we have the numerical value, which is 2, right? We have the value in the middle, which is k to the 10th, right? And then we have the last one, which is m to the 3rd. So basically what's going to happen is that 6, that exponent 6 outside, will be applied to the 2, to the k to the 10th, and then the k to the 3rd. So the way this is going to look, it's going to be 2 to the 6th power times k10 to the 6th power times m3 to the 6th power. Basically, I separated all of them. They're still multiplying, but now we see that 6, the exponent 6 is being applied to each one individually. So it's more visually appealing to us to notice that they are separated. So 2 to the 6th power is 64. Then k10 and then to the 6 becomes 10 times 6. And then we have times m 3 times 6, right? So again, we're multiplying those exponents. So this becomes 64, k to the 60, m to the 18. And this is the simplified version of our example. Let's try another one. So we have negative r to the 2nd power and then s to the 8th power and then everything to the 3rd power. So basically for this one, again, we want to separate everything. So what I'm going to do is notice how at the beginning we have that negative, right? I'm going to count this as a negative 1. Okay. Then we have r to the 2nd power. And then we have s to the 8th power. So those are the three groups that I'm going to be separating. And then 3 will be distributed, right? To negative 1, to r to the 2nd power, and then to s to the 8th power. So I'm going to have negative 1 to the 3rd power times r squared to the 3rd power times s 8th to the 3rd power. Now we know that negative 1 to the 3rd power is negative 1 times negative 1 times negative 1, which is going to give us negative 1. And then times r to the 2 times 3. and then times s to the 8 times 3. So this will become negative r to the 6 s to the 24. And that is our simplified answer. Let's go ahead and try a last one. So we have negative 4 times 3 and then tu to the second power. So for this one, let's keep in mind that this exponent 2, it's only affecting whatever is inside of the parentheses. So that exponent 2, it's not affecting the negative 4. So the negative 4 outside of the parentheses is going to be on the side. We're not going to distribute that exponent to the negative 4. However, that exponent will be applied to the 3, to the t, and to the u. Okay. So to the 3, to the t, and to the u. So this will become negative 4, and then 3 squared times t to the second power times u to the second power. And this will become negative 4 times 9 times, oops, let me put it here on the side, times t to the second power, and then times u to the second power, which is going to be negative 36 t squared u squared. So notice how here I just multiply the negative 4 times the 9. And then we kept the two variables with their second power.